All right, so 2.5 is rates of change and particle motion, part 1. So that's kind of a little bit of foreshadowing there, right? Or is that I? Particle motion I. Is that a personal pronoun or a Roman numeral? It's a Roman numeral. So that implies that there's a particle motion part 2. And there will be. Y'all will have a particle motion 2 and 3. The 3 is the BC only. So when we talk about particle motion, particle just represents some object that's moving. You can put yourself into it and become the particle. You can let your dog be the particle. But for right now, we're going to focus on moving left and right or moving up and down. Okay, we're going to limit ourselves to essentially one-dimensional motion. All right, so if F represents a quantity, then of course F prime, or you could write it as dF dx, represents the, as we said, instantaneous rate of change. And so we could talk about how any quantity now that can be modeled by the function F is changing at any given moment. I have some examples in here, like the area of a circle at a given moment. How fast is it changing? The outdoor temperature. Next week this time, I think it's supposed to be in the 60s, I saw. So the amount of rainfall, right? It got a little rain over the weekend and a lot of sunshine. Number of people infected with the disease. Let's hope that happens. Doesn't happen. Sorry, doesn't happen. That could, yeah. Epidemiology, right? They study how diseases spread, and we had swine 09 flu. So yeah, that happens. So we can talk about how fast things are spreading. That change at variable rates, we need calculus for it. So we're going to start by doing what we did kind of in the warm-up today. We're going to start by writing sentences to interpret mathematical sentences, also known as equations. So here's example 1. The temperature, capital T, in degrees Fahrenheit of a cold yam placed in a hot oven. Now, when you read that, that just kind of gets you in the mood for fall, doesn't it? All right, it's like Thanksgiving, get here already. Cold yam, hot oven. Love it, love it, love it. All right, it's given by this. So big T is equal to F of little t. So that means that the temperature is a function of T. This is the time it's been in the hot oven, right? And that makes sense. So this is your independent variable, and this is your dependent variable, right? You can kind of adjust the temperature of the oven, but once it's set, then what you have control over is how long you leave it in there, right? And the temperature then depends now upon how long it's been in there, right? So we might want to know how fast is the temperature of the cold yam changing at any given moment, right? Especially if we're interested in eating it, right? Is it almost done? Well, how fast is the temperature changing at this moment, right? Those are questions you typically ask in the kitchen. All right, so part A, in a complete sentence with units, and that's super important. I can't emphasize that enough because a lot of the times you'll be asked to explain the meaning of something, and if you leave off any of the units on either your dependent or independent variable, even though everything is perfect, you're going to lose the one check that it's worth, okay? We're going to translate the practical meaning of this. F of 20 equals 255. Now, this is a mathematical sentence, believe it or not. You've got your verb is right here. What is that in English, the verb? Yeah, or is, right? You could say it is. The left side is the right side. This 20 is going to be your independent variable, right, of course, but it's also going to be your introductory adverbial clause. This is going to be the start of your sentence. So just like we always start with our independent variable when we're evaluating, you want to keep that in mind. You want to start with that when you do your sentence because that's the part that some people tend to leave off. So here's something else that you could do to kind of help orient yourself. You could draw a little set of axes and start labeling things because now it's not just X and Y. We're measuring big temperature in degrees Fahrenheit on the y-axis, and we're measuring little t time in, what was it, minutes, I believe? Okay, so immediately now you're saying, all right, if I'm evaluating the function at any given time, the units are going to be degrees Fahrenheit. All right, so how would we start this sentence? This gives us the instantaneous temperature, right? So we'll start with, you could say, at t equals 20 minutes. That would be, again, The real straightforward engineering type answer. Of course, you could make that a little bit better because T is the number since the time it's been in the oven. You could say after the cold yam has been in the hot oven for 20 minutes, comma. That's a lot of writing, right? If you just say T equals 20 minutes, you're done with the introductory part. And notice I have units there. Very important. At T equals 20 minutes, comma, what does 255 represent? The temperature of the yam. You can say at T equals 20 minutes, comma, the yam's temperature. Try not to use the passive voice, right? Instead of saying the temperature of the yam, we'll say the yam's temperature. Who does the temperature belong to? The yam, right? Let's give it to him. It's the yam's temperature is 255, period. Degrees Fahrenheit, yeah. Degrees Fahrenheit, exclamation point, right? Is that allowed? Yeah, absolutely. Yeah, that gives that sentence a certain je ne sais quoi. People look at him like, oh, this guy, he's excited about the yam, right? Okay, you want to be careful when you put that after a number, though, right? In a math class, am I right? Factorial. Okay. So, like, if you're on the golf course and you yell 4 factorial, people are going to be like, why is he talking about 24? Why is he yelling 24? Right? The factorial will be, never mind. Okay. Any questions on that? Pretty easy, right? Instantaneous position. But in this case, it's the position of the temperature. It's just a quantity. Nothing calculus-y about that at all. Now, part B, it says, what is the sign of f prime of t? So what you can immediately do is once you write it like this, you could say t prime, which is also f prime of t. Because remember, we define t to be a function of f, or function of little t. What are the units? Well, the units of derivative, since it's a quotient, are always units of y over units of x. So you get degrees Fahrenheit per minute. All right, so what is the sign? And it says y. Any idea? It's positive. Good. The sign of f prime is positive. Comma, because, and what would be the reason? That's how ovens work, or that's how cold yams work. Because the yams temperatures are cool. No, are hot. Yeah, are increasing. The yam's temperature, we'll just say, is increasing. Very good, very good. That is how ovens work, right? It would be rare. I mean, cold and hot are kind of relative terms, aren't they? It'd be kind of rare to like call a hot oven like 70 degrees Fahrenheit and a cold yam like 80 degrees Fahrenheit, right? Then you put it in, the yam actually loses temperature. So we do make some assumptions here. Okay, because the yam's temperature is increased. How does that sound? Perfect. Thank you. Yeah, increasing. There we go, increasing. All right. It's kind of hard to talk and write and think about cold yams in my tummy. All at the same time. What are the units of f prime of 20? Degrees Fahrenheit per minute. Yeah, there you go. Degrees Fahrenheit per minute. What are the units? Degrees Fahrenheit per minute. All right, so now in a complete sentence with units, what's the practical meaning of this sentence? Well, again, we have our independent variable. So we're always going to start with that. And that is going to be then at t equals 20 minutes, comma, and now f prime is measuring the rate of change of the yam's temperature. So this is where some students kind of miss the mark a little bit. Whenever you're interpreting a derivative, you always want to say either increasing or decreasing, or say something that's equivalent to increasing or decreasing, like falling with the, what was it, a banana that we dropped? No, a meatball. Yeah. So at t equals 20 minutes, comma, the yam's temperature is what? Good. Is increasing or rising would work? Yeah. is increasing by, and then it's 2, and here's where you want to be careful with your verbal explanation. You don't want to just say 2 degrees Fahrenheit / minute, okay? Because that's not interpreting it. If you're talking about the temperature increasing, you want to list it as units of temperature and then write out per separately per minute. And if you think that you're going to not know when to do that, think about using a different word besides per, like each minute or every minute or something like that. Every minute, per minute, and then period. Okay, so you always interpret the vector as a direction, okay, so the temperature is increasing, and then the magnitude of the vector. So had that been negative, that wouldn't make sense in the oven situation, but had that been negative, we would say the temperature is decreasing still by +2, okay? So you have a numeric answer that could be positive or negative with units, and then you interpret it always with the direction and the scalar quantity. And then did I put units on both my independent and dependent variable? I got minutes and degrees Fahrenheit each or per every minute. Yeah, got it. So it's not that difficult, but I do see students sometimes, missing the mark. If you just set a t = 20 and you didn't put minutes, you wouldn't get the check. Okay? All right. So we kind of know a lot about the yam right now, don't we, at t = 20 minutes? We can almost write like a children's book, like a 2-page children's book, right? The Adventure of the Yam, right? The cold yam is put into the hot oven, right? Page 2. You can imagine the wonderful illustrations here. At t = 20 minutes, the yam is 255 degree minutes, and its temperature at that exact same moment is increasing by, whatever we said, 2 degrees Fahrenheit each and every minute. The end, right? And that kind of leaves it open for a sequel, right? All right. Yeah, and that'll be the sequel, right? And that keeps them buying more books, right? It's just a writer's technique. All right. Any comments or questions about this? You know where I got this question from? Not from like the Fall Harvest Festival. I got this from a Harvard worksheet back in the day. Like when I first started teaching, I was kind of scouring resources. And, of course, I went straight to Harvard. That was the first place I went. And I looked at their calculus course, and there was a worksheet on there, and it had this question. So I'm like, hey, it's good enough for Harvard. It's good enough for us, right? So I stole it. In case you're wondering why I was thinking about cold yams, like I don't have just like this food fetish or anything for cold yams. Like, of all things to put in an oven, right? A yam? So anyway, there you go. Do you all feel smarter now knowing that you're doing what Harvard students are doing? Yeah. Actually, Harvard students should feel smarter because now they're doing what New Braunfels High School UC Calculus students are doing. There you go. There you go. Turn the tables. Okay. No, remember the units of the derivative will always be the y-axis units over the x-axis units. It's a division process. The derivative is division. Division, derivative, derivative, division. Okay? And that's why I kind of still prefer Leibniz notation, because you kind of have that dimensional analysis thing that you could fall back on, or stoichiometry, right? It's going to be units of y over units of x. So derivative is division. Later on, it's going to turn out that integration, which is the second half of the house of calculus, is multiplication, right? Okay, example 2. An ice cream company. Ooh, yeah, dessert, right? Okay. Now, it's kind of interesting if you just read that first part up to there, it always kind of creeps me out a little bit, right? Because just read it and just kind of imagine. An ice cream company knows. What do they know? It kind of sounds foreboding, right? Who gave them? Why do they know so much, right? An ice cream company knows. Well, here's what they know. They know that the cost C in dollars to produce Q quarts of cookie dough ice cream. I added that. I think Harvard was just plain old vanilla. Cookie dough ice cream is a function in part, right? There are many variables that go into things, but it's a function in part of the number of quarts they produce, right? That makes sense. So little q is the independent variable. Produce more quarts, the cost is going to go up, right? Produce fewer quarts, maybe the cost goes down. But the cost depends in part on how many quarts are produced. All right, so let's go ahead and draw our little first quadrant thing just to kind of orient ourselves. We got the cost to produce in dollars on the y-axis, and then we have the independent variable Q, which is measured in quarts. So right away we could say C prime or F prime is going to have units of what? Dollars divided by quarts. So you can get it set up right away. So you're setting yourself up to answer any type of question. Okay. If F of 200 is 70, explain in a full sentence what this means in terms of the problem. Okay. So 200 is our independent variable, and it represents what? Dollars or quarts? Quarts. So you could say when Q equals 200 quarts. Again, that would be kind of the engineering response, which is just straightforward. You know, you leave the rephrasing to the English people. But you could also say at the 200 quart production level, right? It would be the same thing. It's just a lot more writing. When Q equals 200 quarts, boom, you're getting that check. What is 70 units? Is that dollars per quart? It's just the cost. When Q equals 200 quarts, comma, the production cost is a good way to say it. The production cost is $70. Okay, and you can write dollars like that, or you can actually put 70 and write the word dollars out. Either way, that's a customary unit, right, to put it in the front. Well, we put dollars in the front, dollar unit signs in the front, and cent signs in the back. Have you ever noticed that? Yeah. Have you ever started writing something dollars, and then you realize you didn't even leave enough space in the front for dollars? Then you have to kind of squeeze it in, or is that just me? Okay. Is that good? Does that answer the question? I think so. Part B, you do this one now, okay? If F prime of 200 is equal to 3, explain what that means. You can see we're kind of gathering information for another children's book. It gets more exciting. If you're bored with cookie dough ice cream or something, you can replace it with something like, I don't know, Rocky Road, and then just imagine that you have a severe nut allergy. And that makes the problem a lot more exciting. My wife has a nut allergy, so it's kind of something we always have to consider. All right, if F prime of 200 equals 3. So I know the 200 is still my independent variable. It's whether it's F or F prime, that's still your same independent variable. So when Q equals 200 quarts, okay, so again, you're referencing the moment in time with units. And what is 3? What'd you say, Jack? When Q equals 200 quarts, comma, what'd you say?
The amount of dollars is increasing, or the cost is increasing by $3 per quart.
Yeah, exactly. Yeah, when Q equals 200 quarts, comma. I'll just throw another word in there, an adjective, the production cost, but you could just say the cost because that's what we're referring to. The production cost is not $3, but is, again, increasing. And how do we know it's increasing? It's a positive number. It's increasing by $3. And again, do you want to do this? Slash quart? No, not in the sentence, okay? Because if you're talking about a rate and change of production cost, you want to give it in terms of units of cost and then write out per quart. Okay, so your sentence just kind of breaks it down and analyzes it a little bit better. Production cost is increasing by $3 per quart. So that would be kind of like what we call in economics the marginal cost, right? That would be the slope of the tangent line at 200, and they can use that slope of 200 over 1 quart to kind of predict into the future. And it's not going to be exact, right? But it's a good approximation of what it would cost to make 1 more quart. And then they can compare that to, the revenue they would get and how much profit, their marginal profit, and decide if they want to do that or not, okay? Sweet. How about this one? If F double prime of 200 is negative 0.1, explain what that means. Go for it. This one's a little bit trickier. All right, so if you got it, that's fine. The independent variable is still 200, but if you do F double prime, let's think about this. We know that F prime has units of dollars per quart. So if we wanted to sketch F prime, which is really cost prime, we now have dollars per quart on the y-axis, still against Q quarts. Quarts, there we go. And so the second derivative is going to give you the rate of change of the cost increase. And it's going to, again, have units of y over x, which will be dollars per quart, or dollars per quart squared. So that would be kind of analogous to the what of a moving object? The acceleration, right? So the cost itself would be like the position. C prime would be like the velocity of the costs, how fast they're changing, and then this would be like the acceleration of the costs. And so we know the costs are increasing, and this tells us how fast that rate is changing, and it's negative, so the costs are increasing at a what kind of rate? Decreasing rate. So yeah, if you were looking back up here at the original cost function, at the 200 production level, the graph is increasing at a decreasing rate. So we would say something like that, right? The costs are still going up, but by less and less. That might be a good thing, right? It's kind of like maybe implies economies of scale, right? There's a lot of money involved on the setup of something, you know, equipment, recipes, and all that stuff. But at a certain point, as you produce more and more, it's still going to cost you more, but less and less and less, you're offsetting your costs. So that could be a good thing. So let's go ahead and start the sentence. When Q equals 200 quarts, did anybody venture a sentence here, comma?
The change in cost of the production value is decreasing.
Yeah. Yeah, there you go. It's the change in production costs, because we're talking about the double derivative, so it's the change in the first derivative, which is the change in production costs. The change in production costs is decreasing, as you said. Good, decreasing by, so that interprets the sign, and now it's going to be 0.1. I'm just going to go ahead and write it out this time. Dollars per quart. You could do that, but then you're going to say per quart. Okay, because we're talking about the change in production costs, we measure that in dollars per quart, and then per quart. Yeah. You could also maybe add one other thing here. You could change the word change with something, because change is kind of generic, which is okay. What could we say there instead? The increase, yeah, that would actually be a little bit more descriptive. Because when we say the change in production costs, we don't know if the costs are increasing or decreasing. So that would be a slight improvement. All right, super. So we got example 1 and 2 done, and I lost track of time, which goes to show time flies when you are having fun. So anyway, enjoy the rest of your Columbus Day. May you not get lost, and if you do, may you serendipitously discover a new country. Okay, and go Cleveland.